Hello guys, it's a pleasure to meet you again. I'm Berta Monserrat Molina Guzman and I'm going to be your teacher today. Okay guys, first of all, please make the same as me. If I ask you what are you doing, which is your answer? Okay, the answer is a little obvious. You move your hand. The key word is move because today we're going to learn about a special kind of movement, uniformly accelerated rectilinear motion, U.A.R.M. Okay, today we're going to learn about this kind of movement and their equations. Keep in mind the phrase of the day. Archive the excellent and share it from San Ignacio de Loyola. Please guys, always make your best and try to help other ones with that. What do we know about uniformly accelerated rectilinear motion? Guys, try to answer the next questions by yourself. What do I understand by movement? What do I understand by accelerating? What could uniformly accelerate mean? Okay, for the first one, movement is the change of the position in the space. Accelerating is when you change the velocity, and it's uniformly accelerated with the acceleration is constant, and the velocity change the same rate all the time. Learning objectives from this lesson going to be learning about uniformly accelerated rectilinear movement and its importance and its relation to our daily lives. Learn how to use equations to solve exercise where it's requires to calculate a variable in base of the available information. At the end of this lesson, you will be able to recognize and interpret examples of uniformly accelerated rectilinear motion in our daily lives and solve examples involving the questions U.A.R.M. Okay, movement is everywhere, guys. You're fast flying, dogs playing at the park, when you go to travel, or maybe when you're playing with your friends. Imagine the next situation. Are you waiting for the bus to go to your school? It usually is very punctual, 6:30 and arrive. But today it's 15 minutes before the 7 o'clock and doesn't appear. So your dad decides to take you at the school. However, in the usual velocity, you will not arrive on time. So what does it to do? Well, guys, you need to increase the velocity. You need to accelerate. For this lesson, you require a little fundamental concepts. First one, it's movement. Movement is the change of the position or place or a body in the space. Displacement is the length and direction of a body travels to the initial point to the final point. Here in the picture is move. And in the second picture, if you go out of the house, you displacement. Now, velocity is a relation between the space covered by an object and the time used for it and its direction, like a race car. In other words, is the distance and the time. But it's very important the direction because if you don't give the direction, you only give the speed. Finally, acceleration is the rate of change of the velocity over the time. In the picture, the guys they see increase the velocity, but not all the times you increase. Now, it's very important to remember the difference between scalar quantities and vectorial quantities. A scalar quantity is described with only number and units, or in other words, with a magnitude. But vectorial quantities require a magnitude and a direction in the space. For example, if I ask you for the speed, you will only tell me 130 kilometers per hour, and it's correct. But if I ask you for the velocity, you need to give me the direction too. Maybe left, maybe the right. This is the maximum velocity for a cheetah. Now, rectilinear movement is the one whose path is a straight line. In the first picture, you have a rectilinear movement, but in the second one, isn't it? Yeah, uniformly accelerate, it means that the acceleration is constant. So, in other words, bodies will move in a straight line with a constant acceleration, have this kind of movement. Or the velocity of the object going to change the same rate all the time. In the draw, you could see the velocity increase 2 meters by second each second. Now, if you look for that topic, maybe you find this kind of graphics. But don't worry, in the future, we're going to learn how to read them. For the moment, try to remember about this movement and it's in ordinary legs. For example, an skateboard, or maybe about who falls, or a bike on the street. If you try to find maybe the distance, the time you require to arrive at a certain point, or maybe the velocity or the acceleration, you could use the next equations. With these four equations, if you have three variables, you could find the rest of them. In this equation, the x is meaning position. It's a point in the space. X0 is a steady point when the time is equal to 0. Bx is the velocity and an x point, sometimes the final point. B subbind the 0 is because it's the initial velocity when the time is 0. T is for time, and finally, acceleration, remember, always going to be constant. I have some advices to you. The first one is the units. Must be the same. Use the international system. In this example, the red. If you make the operation, you're going to get 2 meters, minutes per second. And what means that? You don't have any magnitude, neither distance, time, on another one. But if I change the minute at seconds, I'm going to have the green one. 60 seconds for 2 meters by second. I'm going to have meters, seconds between seconds. And for mathematics, you know, all the numbers divided between themselves are equal to 1 and disappear. So I want to get 120 meters. If the exercise told you that a body is in rest or repose, it's because the initial velocity is 0. But if the exercise told you that break or stop, it's because the final velocity is 0. Now, we're going to make some exercise. The first one, we could use again the example of the beginning of the lesson. The car was at rest, and you head towards the school with a constant acceleration, the 1 meter by second square, for half a minute. How far did you travel? Okay, guys, for resolve that kind of exercise in physics, the first step you need to make is a draw. Make a little draw, don't need to be very detailed, but put them all the relevant information. In the exercise I told you was a rest, so my initial velocity is 0. My initial position is 0 too. Why? Because I select the axis in my house and I begin in my travel. The acceleration is 1 meter per second square and my time is half minutes. So they ask me for the distance. The next step I need to make is change the units. I have minutes for time and I require half seconds. So I'm going to have all with the same units. For that, I need to use the next factor. Remember, dimensional analysis. If you want to disappear one unit, that unit needs to be under the line. And the unit I want to have is over the line. So I know each minute give me 60 seconds. Seconds over, minutes under. I have seconds by minutes per minute. Disappear the minutes and I have 30 seconds. Now, I need to look for all my equations, which of them I could use. In this case, I could use one of them in a direct way. Next one. Or I only need to replace the variables with the values. So, it's that. Now, I need to make the operation. First one, I have a squaring. So, I'm going to get that. 30 square, 900. Second square. So I make the operation. By 1, 900 meters second square per second square. Second square between second square disappear. I have only meters. Between 2, 450 meters. For the next term, I have time and I have the initial velocity. But my initial velocity is 0. And remember, all numbers multiplied by 0 are 0. So I have 0 and my initial position is 0 too. So my final point going to be 450 meters. Now they ask me for the distance, the difference between the final point and the beginning. Now, if I rest 0, I'm going to get a distance of 450 meters. Okay, guys, any question? If it's like that, make the same exercise. The next exercise, you need to obtain the new time. The school is located 1 kilometer from your house, so you decide to change the acceleration. This time, the acceleration is 2 meters by second square. So, how long will it take you to get to the school? Try to stop the video and make that by yourself. Okay, guys, I need to make the draw, but check something very interesting about this exercise. My initial velocity going to be the final velocity for the previous exercise, and I don't have that. My initial point going to be the final point for my previous exercise, 450 meters. The acceleration going to be 2 meters by second square, and my final point going to be 1 kilometer. They asked me for the time. So the first step I need to make is change the units. I have kilometers. I want to have meters. I know the kilo means 1,000. So 1 kilometers have 1,000 meters. I make the operation kilometers. Between kilometers disappear and I get meters. After that, I need to obtain the initial velocity. So I'm going to make this next equation, but with my information for the previous exercise. My initial velocity was 0. My initial acceleration going to be 1 meters by second square, and my time going to be 30 seconds. So I write it. I make the operation 30 for 1, 30 meters, second square. Second square less 1 second. So I get meters per second. My initial velocity in this exercise and my final velocity in the previous exercise is 30 meters by second. Now, guys, remember, you have a lot of ways to resolve an exercise. Today, I'm going to teach you one of them. Why? Because this method is going to give you a new equation, and this equation is very useful to you. But don't worry if you resolve in another way. First of all, I'm going to use this equation. If you check, you have the t 2 times. So I'm going to equal to 0. After that, you check a very similar to another kind of questions. This is a second degree equation. So I could resolve that with all the formula general. So my z is the initial point less the final point. My v is initial velocity, and my a is the half of the acceleration. So I need to leave alone the square. I'm going to multiply all the equation for the inverse of its coefficient. Why? Because I require that that coefficient disappear. And I need to use all the equation because I need to keep the quantity. Remember, the things you made in one side of the equation, you need to make the same in the other side. So I'm going to multiply all of that for the inverse of the coefficient, 2 between acceleration. I get the next expression. Now I have 2 acceleration between 2 acceleration. So in mathematics, again, it's 1, so disappear. Now the t squared is alone. Next step, I need to complete the perfect square trinomial. I'm going to add in on both sides the next factor to maintain the equality. Well, the numbers in the middle going to be all under the line and over going to be the extremes. Now I have 2 between 2 disappear. I get initial velocity between the acceleration, all of that is squared. So I write that factor in the both sides of the equation. Now, I need to pass to the other side the term with the distance. Why? Because I want to keep along the perfect trinomial. Now, with the perfect square trinomial, I could factor that. Use the next rule. If you check here, I require the square root of the t square and the square root for the other term. So I had t plus initial velocity between acceleration, all of that square. If you want to check, make the operation t squaring, t square. Initial velocity between acceleration squaring, initial velocity between acceleration square. And finally, 2 times the product between A and B. So 2 times T by B per A, 2 times B by T per A. So it's correct. Now I need to squaring the other part, the other term, the blue one. After that, if you check, you could simplify the fraction. Why? Because you have almost the same denominator. I'm going to use the light blue term. Now, I'm going to have exactly the same denominator. So I need to multiply for the acceleration, the denominator. But for keep the equality, I need to multiply by 1. So I'm going to multiply and divide for acceleration. I have the next term. I write them. Now I have exactly the same denominator. So I will simplify. Next, I need to get the square root of both parts to eliminate the power. Remember, we have a little rule for the powers. If you get the root for a number and a central power, and the power and the root is the same number, going to disappear. In this case, I have 2 between 2, it's 1 and disappear. So I'm going to have along the t and the velocity between the acceleration. But in the other side, if you check, appear two signals. Why? Well, guys, if I ask you forgive me the square root of 9, maybe you told me 3, and it's correct. But negative 3 is other root. If you check, both of them give you 9. So the square root going to give you a positive and a negative result, and I require both of them. Now, I need to develop the operations. Now, remember, if you have a root and that root you have a fraction, you could put the root in both parts of the fraction, the numerator and the denominator. Now, in the denominator, I have the square root for a number of the second power, so going to disappear. Now, I need to let alone the t, so I paste the term in the other side. Finally, I have the same denominator, so I could simplify the factors. And after that, I finish. Guys, if you check, it's very similar to someone you know. The general formula was rate. So, if you check, the A going to be the half of the acceleration, the B going to be the initial velocity, and the C going to be the initial point less the final one. And it's exactly like in the beginning of the exercise. Guys, don't worry, you only require this equation. Now we call return to the exercise. In example 2, the school is located 1 kilometer from your house. So you decide to change the acceleration. Now it's 2 meters by second square. How long will it take you to get to school? Okay, my drawing, my information with the exactly same units. And I have a new equation. I'm going to put that. Now I change the variables for the values and I develop the operations. 450 less 1,000, 550 meters by 2, 1,100 by less 2, going to be now positive because remember was negative. 2,200. And after that, I add 900 for the theory squaring, and I'm going to get the square root of all of that. 55.67 meters by second. Why? Check the units. You have meters. For meters, meter squared between second squared. But you have a square root, so going to disappear and only get meters by seconds. Now, remember, you have a positive and a negative. So for the first one, I'm going to use the positive. If I keep 30 meters by second and I divide between 2, I'm going to get 12.83 seconds. But if I use the other one, I'm going to get 42.83 seconds. Guys, when you have a question with a second degree, you're always going to get 2 results. But don't worry, it's very easy to identify which is the correct. Why? Because only one of them is logic, with the statement, with the reality. For example, you could travel through the time. Maybe you are Superman or Flash. I really don't think that. So you could only use the positive result. So the time you require is 13 seconds. Now, guys, remember, you always have more than one way to resolve the exercise. Try to make again the example 2, but this time use the next equation to get the final velocity. And after that, try to obtain the time solving the following equation. Okay, guys, in conclusion, uniformly accelerated rectilinear motion is identified by going in a straight line and increasing velocity steadily. When solving U.A.R.M exercise, it must be identified which of the question is most useful based on the available information. As long as there are 3 values, it is possible to obtain the rest of the variables. Okay, guys, this is all for today. Thank you so much. There are my reference and the reference for the pictures. Guys, any questions? If you have questions, you could write them in the video. Well, in the comments. Thank you, guys. Today advance. Congratulations, you have come a long way and you know more about the uniformity, accelerated rectilinear movement and its equations. And you improve a lot your competence and skills, the critical thinking, read and understand text, extract relevant information and use in the problem solving, and finally learn autonomously. Okay, guys, if you go to the next page, you're going to find some extra material, especially a page when you could go and make simulation about this kind of movement. See the graphics and maybe resolve some questions. Okay, guys, remember you have some houses, so try to make very proud of them. Have a nice day. Thank you so much. God bless you. Bye.